Here we have problem number 19. So we have a block of mass stays at rest. So it has kinetic friction. When arrow of mass 280 grams strikes the block with a speed of 80 meters per second, and it stacks in the block. So we have to find the distance to which block with arrow will slide after strikes till they come to the rest. Okay, so let's draw a picture first of all. So here we have horizontal surface. Here we have our block. So let's make it capital M, the mass. Then here we have arrow. It has small mass. So just before hitting the block, it has initial velocity. Okay. Now, after that, it hits the block, it embeds and it slides. So suppose that it moved a certain distance, okay, before it stops. So it also has kinetic friction, mu. What else? So we have to find a distance when block stops. So how can we find it? So we can use conservation of momentum first of all, which is states that initial momentum is equal to the final momentum. Initially, the only arrow was flying, so therefore mass of the arrow, initial velocity of the arrow, plus 0 because initially the block was not moving. But after heating, it embedded and it moved together, so therefore V final is equal mass of the block plus mass of the arrow. Okay, now you should keep in mind that this V final is just when it hit the block and it starts moving. Okay, so therefore we can say that also that when it moves a certain distance, V final 2 becomes 0, okay, when it stops and when it moves certain distance. Okay, the first of all, let's find what is this velocity. Okay, so we are considering first of all this part. Okay, so let's call this the first part, and this is, I call it second part. Okay, so what happens in the first part? So in the first part, so V final using the conservation momentum is equal mv initial divided by the mass of the block plus mass of the arrow. Okay, so if you do calculated, you're supposed to get 18.98. Okay, so you get 18 point. Okay, problem number 19. Okay, so all the data is given here. So the final velocity becomes this 1 meter per second. Okay, now we have to consider particularly this part. Okay, what's happening there? So in this part, which is part 2, we have to use conservation of the energy, which is energy initial is equal to the energy final. Initially, what we have? Initially, we have this kinetic energy. So let's call it V initial, okay? Kinetic energy initial is equal to the work done by a friction, okay? So that means we can say that it is mv initial over 2, which is V final here from first part, is equal work done by friction, which is friction force times distance. Or you can say friction is equal to the mu kinetic multiplied to the normal force multiplied to the d. and your normal force is equal to the mg, correct? So therefore you can say that mu k mg d distance. So from there, finally your d distance will be equal to the mv initial squared divided by the 2 mu k mg. So m will cancel with this one, and finally v initial squared divided by 2 mu k g. Okay, so that's it. So this is your final formula. So you should keep in mind that this v initial in the second part is equal to the v final, which is from the first part. Okay, this is from first part and this is from second part. That's it.